So, right at the heart of this whole AI revolution, a really critical flaw has just been found. It's a major threat to the very tools that are building our intelligent future, and it goes by the name CVE 2025-64712. And look, when I say critical, I'm not exaggerating. This thing scores a 9.8 out of 10 on the severity scale. To give you an idea of what that means, that's basically the digital equivalent of a 5-alarm fire. We're talking red alerts, sirens blaring. It's a massive problem.
So who's in the line of fire here? Well, this isn't some piece of obscure software nobody uses. We're talking about major tech players, giants like Amazon and Google. They're at serious risk because this flaw hits a core part of their modern AI system.
Yeah, this isn't just another bug in the system. It's a hidden danger lurking right inside the tools we're using to build the future of AI. The flaw itself, it's hiding in this super popular library from a company called Unstructured IO. And to really get why this is a huge deal, you gotta understand what fuels all of modern AI: data.
You see, the stuff that powers this whole AI boom, well, it's got a dirty little secret. It's messy, it's chaotic, and there is just a mind-boggling amount of it. Let's take a look at just how much.
The scale of this is just wild. Think about it. A whopping 85% of all the data a company has is unstructured. We're talking about everything: PDFs, Word docs, emails, presentations, all of it. It's an absolute goldmine of information, but for an AI in its raw form, it's completely useless. And that right there is where Unstructured.io steps in. The best way to think of it is like a digital refinery. It takes all of that messy, raw data and transforms it into clean, organized text that an AI can actually understand. It's an absolutely critical link in the chain.
Now, on the surface, the process seems pretty simple, but it is absolutely vital. First, the pipeline pulls in raw files from all over the place. Then it gets to work extracting and cleaning up all the text. And finally, it loads that clean, useful data into the AI systems ready to go.
So, the big question is, how does a hacker actually break this critical chain? Well, it's kind of funny actually. They use a classic, almost old-school trick on one of the most modern systems out there.
Okay, so the attack itself is called path traversal, and the idea is pretty simple. You trick a program into saving a file somewhere it shouldn't. It's kind of like telling a courier to drop a package in the mailroom, but you secretly slip them instructions to leave it in the CEO's office instead. And in this specific case, the whole thing gets kicked off by a very particular type of file, an email attachment from a Microsoft Outlook .msg file.
Okay, so let's look at how this is supposed to work, right? When the system gets an attachment, it's designed to save it in a safe, temporary folder. A totally harmless spot where it can't cause any trouble. Everything's nice and contained.
But here's the trick. The attacker crafts the specially made malicious file name. You see that // part? In computer language, that just means go up one folder. So, by stringing a few of those together, the attacker is telling the system to walk backwards, right out of that safe, temporary folder.
And boom. Here's what happens. Because the system isn't double-checking that file name, it just follows the instructions. It walks right out of that temp folder and overwrites a supercritical system file called authorized keys. That file, just so you know, is basically the bouncer for the server. It decides who gets remote access. It holds the keys to the kingdom.
The security researchers over at Sierra, the ones who actually found this, put it perfectly. They said this allows an attacker to overwrite that file with their own key. The result? Complete and persistent access to the server. It's not just breaking in, it's like being given a permanent key to the front door.
Okay, let's pull back for a second, because the real danger here isn't just about one compromised server. It's this massive ripple effect. It's about why this type of bug is so sneaky and so dangerous for the whole tech world.
What every hacker is dreaming of is something called remote code execution, or RCE for short. And you really don't need to be a tech expert to get this one. RCE means total takeover. The attacker can run any command they want, steal any data, do anything. It is, quite simply, game over.
And what makes this vulnerability so incredibly risky is that it's just this perfect storm of problems. First, this little library is often buried deep inside other software. It's a dependency of a dependency. Companies might not even know they're running it. Second, these data pipelines often have really high-level permissions. And third, their whole job is to process files from untrusted places. You put that all together, and you have a massive blast radius.
All right, so that's the scary part. The good news? We know how to defend against this. And, while the vulnerability is definitely severe,
The fixes are all based on well-known, solid security principles.
It really comes down to a few key strategies. First, you have to isolate the whole process in what's called a sandbox container. That way, if something goes wrong, the damage is contained. Second, you never ever run these things as the all-powerful root user. Always use a low-privileged account. And third, you put security checks in place to spot and block those malicious ... sequences before they can ever do any harm.
Look, at the end of the day, this vulnerability is a huge wake-up call. As we keep racing forward, feeding more and more of our digital lives into these AIs, we have to stop and ask ourselves a really important question. Are we actually building this incredible future on a secure foundation, or are we accidentally leaving all the doors and windows wide open?